In this video, we will look at how to connect brushless motor controllers to a Linux computer. Specifically, we will use a Debian Linux computer. The same steps would work for Ubuntu Linux and other Linux distributions derived from Debian. The brushless motor controllers come in several form factors with either a circular or a rectangular shape. The controllers come with a set of connectors for motors and encoders as well as for USB or CANbus networks. I've got a small sensorless brushless motor, and a bigger brushless motor with a built-in absolute encoder. Let's look at how to control those from my Debian Linux computer. The controllers can be powered by a power supply unit or by a battery. To spice up my setup, I am going to use a battery to power the controllers and thus their motors. The controllers need 7 to 60 volts DC of voltage input. If I connect the battery, the controllers get powered up. The small LED lights tells us that the controllers are happy with the power supply. Now, we need to connect the brushless motor controllers to the Linux computer. There are two ways to do that, via CANbus or via USB. Let's look at the USB option first. A regular USB cable is used. Only one of the controllers needs to be connected to a computer or a PLC. Next, we need to build an internal CANbus network between the controllers. We are going to use a CANbus cross cable to interconnect the controllers. Each controller comes with two identical CANbus ports that help chain multiple controllers together in a network. If one of the interconnected brushless motor controllers is connected to a computer via USB, then that particular controller becomes a USB to CANbus gateway for the rest of the network. Let's plug the motors to their controllers. The simple sensorless motor has just 3-phase wires. Unplug the power supply before connecting the motors. The more complicated bigger motor comes with 3-phase wires, a ground wire, and an absolute encoder cable. For now, I will connect just the phase wires and the ground wire. The controllers come with blade terminals for connecting the motors. The terminals are designated as A, B, C and G. There are also soldering holes for the motor cables. Now, let's power up our motor controllers, and turn our attention to Debian Linux computer. The controller connected to the computer appears to Linux as a virtual serial port. If we list all the serial devices in Linux, we shall find our controller in the list. Here it is. The controllers use text messages to deliver telemetry data to the computer. We are going to look at the messages now. This command is supposed to display text messages that the controller sends to the computer. Well, what happened is that Linux prevented us from accessing the serial port due to some default security restrictions. To lift the restrictions, we need to add the current user account to a user group called dial-out. The group lists the users who are allowed to access serial ports. You have to invoke administrative privileges to add yourself to the dial-out group. Use the add user command in Debian, or an equivalent usermod command in Ubuntu. Linux requires you to log out and log in again for the updated security permissions to go into effect. Let's try display telemetry messages again. It worked this time. The controller encodes telemetry in a text string. We will look into the format of the string in a separate video. One more thing. If you plug the USB cable, and then immediately try to connect to the serial port, you may observe a device busy error. The ghost error disappears on its own in a few seconds as you keep trying to connect to the port. This issue can be fixed. What happens is that a standard Linux program called Modem Manager automatically connects to the serial port, thus preventing you from accessing it. The simplest way to fix the problem is to uninstall the Modem Manager using a purge command. Now that we have finished configuring Linux, we can install a graphical software tool called Servoscope. Unzip the downloaded package in your home directory. Open a terminal, and go to the directory with unzipped files. Launch the Servoscope program by executing this shell script in the following way. The Servoscope program provides means to configure your brushless motor controllers, read telemetry, send commands to the controllers, plot performance charts, and so on. Pick the name of the proper serial port in the drop-down menu, and click the Connect button. If the port is not listed in the drop-down menu, click the Refresh button. Both controllers appear in a list of devices. Double-click on a device name to open a command and configuration window. The window has a telemetry and a configuration management sections. You can monitor multiple controllers at the same time. We will look into the Servoscope software with a great detail in a separate video. At this time, you may wish to check input voltage displayed in the telemetry section. Well, it's time to run the motors. I am going to launch an auto-configuration procedure for the bigger motor first. What I am going to show next is just a demo of the controller's auto-configuration function. I suggest that you watch a dedicated video regarding the auto-configuration function, since this topic requires some background information. From the drop-down menu, select the auto-configuration command. Specify a maximum phase-to-phase electric current that your motor can handle. Specify the number of poles your motor has. Click the Send button. The motor produces a beep sound. The sound indicates the beginning of an auto-configuration procedure. The controller sends sounding electrical signals to the motor. This way the controller measures various characteristics of the motor, and then configures itself for this particular motor. The motor makes what looks like mysterious kung fu moves during the auto-configuration routine. The motor accelerates to its maximum speed. Be careful as the motor is producing its maximum torque at this moment. The rapid accelerations may take place a few times during the auto configuration procedure. The second beep sound indicates the end of the auto configuration procedure. Now we need to repeat the routine for the smaller motor. Switch to the other window. Pick Auto Configuration command from the drop-down menu. Specify a maximum phase-to-phase electric current that your motor can handle. Specify the number of poles your motor has. By the way, these values normally come from the motor's datasheet. Click the Send button. This time the smaller motor produces the beep sound and starts making the Kung Fu moves. The beauty of the auto configuration function is that the controller automatically configures itself when commissioning a new motor. Once again, I suggest that you watch a separate video dedicated to peculiarities of the auto configuration routine. Now that both controllers have been configured, I am going to send an electronic speed control command to the bigger motor. Choose Electronic Speed Control command from the same drop-down menu. I specified speed as 20 electrical revolutions per second. Hit the Send button. Note that the program sends the commands to the serial port in a text format. The motor starts spinning with the commanded speed. Here is 100 electrical revolutions per second. Reverse 100 revolutions per second. Forward 200 revolutions per second. Stop command. Now, let's run both motors together, starting the small motor first. The bigger motor goes next. Issuing the stop commands to both motors. That's it for now. In this video we looked at how to connect brushless motor controllers to a Linux computer via USB. We will look at CANbus interface option in a separate video. Make sure you subscribe to our YouTube and Telegram channels. See you soon. Thank you for watching.